Hey everyone, welcome back to Cybernetters. I'm Andrew Yick, and today we're diving into the fundamentals of Unix networking. So, whether you're setting up a server, troubleshooting connections, or just curious about how your system talks to the internet, this video is for you. We'll break down key concepts like IP addressing, DNS, and essential commands, all in a way that makes sense. Let's get started. All right, so let's break down how networking actually works. The diagram shown here represents the TCP/IP model, which is how devices communicate over the internet or a local network. Think of it like a multi-layered process where each layer has its own job. At the bottom, we have the physical layer, which is the actual hardware like copper cables, fiber optics, or even Wi-Fi signals. Moving up, the link layer deals with the direct device-to-device communication using ARP and device drivers. Next, the network layer is where IP addresses come into play. It is responsible for figuring out where data needs to go. This is also where the INCP, which is used in ping and trace routes, help with diagnostics. The transport layer brings in the TCP and the UDP, which handles how data gets transmitted. TCP ensures reliability while UDP is faster, but it doesn't check for errors. And finally, at the top, we have the application layer where actual services like SSH, HTTP, and DNS operate. So everything from like loading a website to sending an email relies on this layered structure working together. Now let's go deeper into how Unix systems use this model in practice. All right, so let's talk about setting up a system on a LAN. So if you're connecting a new machine to a network, you can't just plug it in and expect it to work. There's some setup involved. First, you'll need to assign it a unique IP address so it doesn't conflict with other devices. So think of it like giving your computer a home address so the network knows where to send data. Along with that, you'll need a network mask, which helps define the part of the address that belongs to your local network. Next, you'll configure the network interface, which is basically the bridge between your machine and the network. If this is wrong, your system won't be able to communicate properly. Then we need to establish a default route which tells your machine where to send the traffic and when it's trying to reach something outside of the local network. Most of the time, that would be your router. Finally, we need to set up like a DNS server. Why? Because like while your computer understands the IP address, you don't want to type something like 142.250.190 and 78 every time you want to visit Google. DNS translates names like google.com into IP addresses, which makes life easier. So now, once you got all this into place, your system should be able to communicate on the network. Let's now talk about configuring network interfaces. When you're setting up a machine on a network, you need a way to manage its connection, and that's where ifconfig comes in. So think of ifconfig as a tool for telling the system, hey, this is your network card and here's how you should behave on the network. So, what can an ifconfig do? First, it lets you bring an interface up or down. If you're troubleshooting a network issue, sometimes all you need is a quick restart of the interface, just like turning the Wi-Fi on and off and back on. So next, you can assign an IP address and net mask, which is like giving your computer a unique ID on the network so it knows where it belongs. And finally, you can tweak settings like the MTU or the maximum transmission unit, which controls how much data can be sent inside a single packet. So if you're working with high performance networking, tweaking MTU can help optimize speed. So let's break down some of these examples. So what ifconfig if0 up is it turns the network interface on. ifconfig if 192.168.1.2 netmask 255.255.255.0 is where we're given the giving the interface a specific IP and then we're defining the subnet mask. And then ifconfig if0 MTU 9000 is changing the MTU size to 9,000, which can improve performance for large data transfers. So keep in mind that ifconfig is now considered old school and modern systems use IP commands instead, and we'll be talking about later in the video. But knowing ifconfig is still useful for like these legacy systems. Let's talk about routing. Your system needs to know how to send packets to different networks, and the route commands comes in. This is how we tell our system, hey, if you're trying to reach this network, go through this gateway. So the first command, route add, says if you need to reach anything in the 192.168xx range, send it to 192.168.11. The second command, route delete, removes that route. Maybe we changed our network and we don't want traffic going there anymore. Then we have the route add default 172.116.5.1, which sets our default gateway. Basically, if there's no specific route for a destination, just send the traffic to this IP address and let's figure it out. Lastly, the route add host is a more specific route. Instead of routing an entire network, this one says if you need to just reach out to 10.5.3.5, send it to 192.168.11. And if you ever need to check your routing table, you can use the command netstatir on FreeBSD or this route on CentOS to see all the routes that your system knows about. Let's talk about the IP command, which is the newer modern way to configure network interfaces and routing. If you have been using ifconfig and root, it's time to upgrade because those are old school and eventually they're going to be phased out. So first, interface configuration. So if you want to assign an IP address to an interface, we use the command ipaddr which assigns the IP address of 192.168.1.2 with a subnet mask of /24, which is 255.255.255.0 to the ETH0 interface. Do you want to see what's configured? So IP address show will list all the details for that interface. And if we want to remove the IP, we just run ipaddr delete, which is it just removes the IP. And then for routing, instead of using the route command, we would use IP route. So to add a route, we do IP route add via so basically, if you need to get to 192.168.2.x, you send it through 192.168.1.1. And if you want to remove it, you do the same thing but with delete IP. So like you use the command IP route delete. So what if you just want to see all your current routes? So IP route or IP route show will list them. So do you need a reset? IP route flush will clear everything. So IP is the way forward and try to get comfortable with it because ifconfig and route will be basically fossils at this point. All right, so let's talk about where network settings are actually live on your system. So when your machine boots up, it needs to know how to configure these network interfaces, and that information comes from the configuration files. These files tell the system, hey, here's your IP address, here's your gateway, and here's how you should talk to your network. Now, where these files are stored depends on the operating system. So if you're using Linux, specifically CentOS or RHEL, you'll find network settings in etc sysconfig network scripts. This folder contains the individual configuration files for each interface. So if you're setting ETH0, you have a file called ifcfg-0, which you define things like the IP address, the net mask, and whether the interface should be active on boot. There's also etc sysconfig network, which handles system-wide settings, including the default gateway. Think of it like a big picture file that says, this is how my entire system should handle networking. If you're using BSD systems like FreeBSD, the configuration is stored in etc rcconf. This is where you define the interface settings, routing parameters, and the outer networking details that gets applied when the system boots up. So, bottom line, if your network isn't behaving after a reboot, these are the files you want to check first. Let's talk about DNS Name Resolution. How your system knows where to send network traffic when you type a domain name like Cybernetters instead of an IP address. So first, we have the etc hostname. This is where your system stores its own name. So if your machine is called server, this is what would be in the file. Next is etc host. This is like a mini local DNS. So before checking for internet for a name resolution, the system looks here. For example, we can manually map an IP to a name. Like for example, the IP 127.0.0.1 to localhost, and then 192.168.1.2 to the Cybernetters net server, which is useful for local network or overriding for DNS for testing. And then we have the actual DNS servers in resolv.conf. This is where we list our name servers like Google's public DNS. Like the name server could be set to 8888 or 8844. Like we can also set a default domain and search domain so we don't have to type the full host names all the time. And then finally, the nsswitch.conf controls the lookup order. Do we check the Etsy host first or do we go straight to DNS? This is what the file decides. If you send it to host files DNS, the system will check the local files before reaching out to the external DNS servers. So with these three files, you can control how your system resolves the name. If you ever have the DNS issues, this is the first place to check. NIS or NIS Plus, which is formerly known as Sun Yellow Pages, was an early system for centralized authentication and name resolution. It relied on a master server to store user and password data. However, it is mostly obsolete today, which is replaced by more secure and scalable options like LDAP and Kerberos. So that wraps up our deep dive into Unix and Linux networking. And if you want to test your knowledge, head over to cybernetters.net, and we've got quizzes on each topic so you can see how much you've learned. And as always, stay secure and keep learning with Cybernetters.